A glass prism refractive index 1.5 is dipped in water refractive index 4/3 as shown in the figure. A light ray is incident normally on the surface AB. So it doesn't matter whether the light ray is originating from air or from water. Okay, since it is passing normally, the angle of incidence will be equal to 0 degree. So the angle of refraction will also be equal to 0 degree. It reaches the surface BC after total internal reflection. It means that there is a total internal reflection at the surface AC, then it passes BC. Okay, then it passes BC, and okay, after the total internal reflection, after passing through BC, it doesn't matter whatever is the value. Okay, now over here understand that in order to now when I draw this normal over here, when I draw a normal over here, that is this normal, okay, it will be equal to 90 degree. Okay, this normal over here will be equal to 90 degree. So now this angle, let me name this point as D and let me name this point at the surface as E. I can say that angle EDA will be equal to 90 minus theta. Okay, and angle BDE will again be equal to theta. Okay, angle BDE again will be equal to theta. I have applied the simple geometry over here. Okay, so I have got the angle BDE. Now BDE is the angle of that itself is the angle of incidence I. Okay, for the light to be reflected, for the light to be total internally reflected from the surface AC, it is clear that the angle of incidence should be greater than the critical angle. This is the critical angle. Okay, angle of incidence should be greater than the critical angle. So I can say that sin I should be greater than sin IC. Okay, because the sign, the proportionality are direct, it is not directly proportional, but as the angle goes on increasing, the sin value or the sin value that we have found out for that angle will also go on increasing. So sin I should be greater than sin IC. Let us find out the sin IC over here. Okay, so the refractive index over here, that is the refractive index of the glass divided by refractive index of the water, will be equal to 1 by sin IC. So refractive index of the glass is 1.5, which can be written as 3/2. The refractive index of the water is written as 4/3. So when it goes in the numerator, it will be equal to 1 upon sin IC. Okay, so now sin IC over here will be equal to 8/9. Okay, so sin IC will be equal to 8/9. So I can say that sin IC over here should be greater than 8/9. Okay, so over here the angle of incidence or the sin I or sin theta should be greater than 8/9, greater than or equal to 8/9. Now if you consider this part, there are two options over here. There is only one option basically. Okay, there is only one option basically, which is option number A. In option number A, the sin theta is greater than 8/9. This is the only value there, or this is the only condition that should be followed in order to get the total internal reflection, which is option number A.